Good morning, children. Today, second chapter, next chapter of physics. That is chapter 3 in NCERT, motion in a straight line. We have got the revision, quick revision from this chapter. We begin with the path length and displacement. Path length is the distance covered by a moving body. That is also called distance. Displacement is the change of position of two bodies, that's all. Or is the shortest distance between any 2 points in a specific direction. So while dealing with displacement, a direction is needed specifically. Distance, it doesn't have any relation with direction. Distance can never be negative, but displacement can be negative or zero. Distance covered by a moving body can never be zero, can never be negative, but it can be only positive values. Distance and displacement. Distance is the actual path length covered by moving body. Displacement is what? Shortest distance between any 2 points in a specific direction. Displacement can decrease, but distance can never decrease. Distance continuously going on increasing. After that, we have to revise speed and velocity. Speed, rate of change of distance, velocity, rate of change of displacement. Velocity can be negative, speed can never be negative. Speed can decrease while traveling. Speed can decrease, but distance cannot decrease. Speed can increase, distance can increase. Displacement can increase or decrease or become zero. Velocity can increase, decrease or even become zero during motion. A body projected vertically upward at the highest point of its trajectory, its instantaneous velocity becomes zero. So speed, velocity, distance, displacement, this type of questions are very important based on statements. Statement type questions are important. Also graph. If you draw position time graph, slope of position time graph gives velocity. Similarly, area under velocity time graph gives displacement. Area under velocity time graph gives displacement. In this chapter, we mostly discuss bodies moving in a straight line with constant acceleration, or sometimes if acceleration is equal to zero. So either acceleration zero or acceleration non-zero constant. This we are discussing. Acceleration is the rate of change of velocity. Acceleration is a constant, means rate at which velocity is changing is a constant. Acceleration can be positive or negative. Velocity positive or negative, but speed can never be negative. Speed can increase or decrease, but distance cannot decrease. Distance cannot be negative. Distance, speed only can be positive. Okay, kinetic energy we have learned later on. We have learned kinetic energy depends on speed. Kinetic energy speed square. Kinetic energy can never be negative. All the statement type questions can be expected from these topics. Area under velocity time graph gives displacement, not position, but that is change in position. Displacement. Slope of velocity time graph gives acceleration. Slope of position time graph gives velocity. Okay. Now in this chapter, we have to focus mainly on those kinematic equations for constant acceleration. Okay. Let us move through our textbook. Rectilinear motion is that motion moving in a straight line. In kinematics, in one-dimensional motion, body is involved. Linear motion, even with the change of direction. A particle may be moving along a straight line from east to west, and it may change direction from west to east backward. So direction change is also involved. A body thrown upward goes in one direction and reverses the direction in one dimension. So whenever we discuss kinematics in straight line, we have to use a sign convention. Strictly we have to follow that adopted convention. That convention we follow is Cartesian one. Cartesian convention says that upward direction measured quantities are taken positive and downward direction measured quantities are taken negative. For example, when a body is thrown upward, during the course of journey in the upward direction, its velocity is always positive. But during the downward part of its journey, its velocity can be taken as negative. At the highest point of its path, its velocity becomes 0. During upward motion, during upward course of the journey, velocity positive. During downward course of the journey, velocity becomes negative. At the highest point of its trajectory, velocity becomes 0. But throughout the journey, its acceleration, rate of change of velocity is unique. That is a constant both in magnitude and direction. That is acceleration due to gravity, 9.8 meter per second square. And its direction is vertically downward towards center of earth. So during the upward course of journey, velocity directed upward, acceleration directed downward. Repeating, during the upward part of the journey, velocity positive, acceleration negative. But during the downward course of the journey, velocity negative, acceleration negative. See, that interesting results were noticed for the first time by Galileo. And based on that, we have learned many shortcuts regarding falling bodies. Many of the problems can be answered easily by using these Galilean observations. We'll come to that later. Repeating whatever I told before, the basic concept, when a body is thrown upward, the speed of that body decreases. When the body is thrown upward, the speed of the body decreases. As the body moves up, speed decreases. Velocity decreases. At the highest point, velocity, speed both become 0. But its acceleration still is a constant in magnitude as well as direction. At the highest point, instantaneous velocity is 0. But acceleration is minus 9.8 meter per second square. Direction is downward, that is why minus. Okay. So during its course of journey, which one of the following changes? A question may be asked. Acceleration does not change. Speed changes. Velocity changes. Okay. Force does not change. mg does not change. Direction of force, magnitude of force does not change when a body is thrown to little heights. A man can throw only up to few distance above surface of earth so that the value of g is a constant. But it is not true for a rocket which is propelled. There the variation of g is affected. But here only we deal with projectiles. Projectiles are only experienced by gravitational force. And the throw is only for little height, which can be thrown by a man. Of course, by woman also. Okay. Then we discuss bodies which are projected in air, motion under gravity, motion in a straight line, whatever, only in this chapter. Okay, let us continue. Position, path length, displacement, velocity, speed, all these type of problems are important. These graphs are also important. Position time graph is a straight line parallel to time axis. It means its position is constant with the surroundings. Body is stationary, rest. Second one, position time graph is a straight line with inclined, passing through origin. Body starts from origin, moves with constant velocity. Velocity is uniform. Position time graph is a straight line. Slope gives velocity. Slope at any point, a constant means velocity is a constant. Body moves with uniform velocity. So what is the acceleration of this body? 0, because body moves with uniform velocity. That type of questions are important. Next one, position changes non-linearly. That means velocity is not a constant. Slope at any instant varies. So velocity is not a constant. Body moves with variable velocity. Maybe below the graph of a car moving in a street, crowded street. The position increases, then stagnated. Velocity changes. Velocity increased, slope increased at the beginning. Then slope becomes zero, velocity becomes zero. Finally, it came to rest. First started from rest, then came to rest. During that, it moved. Gradually, it picked up velocity, and velocity was increasing. Then velocity was decreasing and became zero. Position at a new position. Initial position 0, new position is close to 300 meter. At 300 meter distance, it came to rest. It accelerated in that time interval. All that is to be explained. Each of those graphs should be explained. Average velocity, total displacement by total time. Average speed, total distance by total time. Average velocity can be 0, but average speed of a moving body can never be 0. Here see this graph. First graph, position time graph for an object moving with positive velocity. Position time graph, velocity positive, straight line, passing through origin, starting from origin, moves with constant velocity. Second one, constant velocity but negative velocity. Negative velocity. What about its acceleration? Students may wrongly assume acceleration is also negative. No, acceleration is 0. Velocity constant means acceleration 0. Third case, position is constant. That means body is at rest. Body is at rest. As time goes, body is at rest. It doesn't change its position with surroundings. So option A, option B, in each of these cases, acceleration 0, but velocity first case positive, second case velocity negative. That graph is to be importantly learned. Next one here, position varies with time. Here you choose 2 points P1 and P2. Here you have 2 points, one P1 and other one P2. At P1 and P2 we know slopes are different, so body moves with variable velocity. You draw a line joining P1 and P2. Draw line joining P1 and P2. That may be called a chord. Okay, you find the slope of that chord. You will get average velocity between that time intervals 5 seconds and 7 seconds. See, at 5 seconds, here 10, 7 seconds, here 27.4. So what's the average velocity? Change in position by change in time. 27.4 minus 10 divided by 7 minus 5. That is the slope of the chord. And that is called the average velocity from 5 seconds to 7 seconds. Like this. Average velocity between any two time intervals is seen to be different. Okay. Average velocity is given. We can calculate by using this equation. Okay. But instantaneous velocity is that velocity at an instant of time. So that time interval is brought to 0. So that you reduce the distance between P1 and P2. Reduce the distance between P1 and P2. Then the time interval is gradually reduced. You can find out the similar slope of that chord of reducing length. Finally, you get a chord which only touches one point. That cannot be called a chord. That is a tangent. So slope of that tangent is called instantaneous velocity. Slope of the chord is called average velocity. Slope of the tangent is called instantaneous velocity. All that we have learned, just revise, that's all. Instantaneous velocity can be defined as mathematically limit delta t tends to 0 delta x by delta t, where delta x by delta t is the average velocity. So limiting value delta t tending to 0, average velocity is called the instantaneous velocity, provided delta t should not be 0, it should tend to 0. That is called the instantaneous velocity. This solved example, students, it's very important. You go through this surely you have to refer this solved example. Example number 3.1. Okay, you see, let me repeat it. Determining the velocity from position time graph. Velocity at t equal to 4 seconds is the slope of tangent to the graph at that instant. So that you reduce the length of that chord, distance between P1 and P2, reduce finally that tangent is that line only touches one point on that curve. So that velocity is the slope of the tangent. It's more important, speed is in general greater than magnitude of velocity. Okay, speed is not necessarily the magnitude of velocity. Always, speed is in general greater than magnitude of the velocity. That's important. Not necessarily modulus. Always. See here, velocity time corresponding to the motion. Velocity increased becomes constant, then velocity decreased. First velocity increased non-linearly, then velocity becomes constant, then velocity decreases linearly. Slope of velocity time graph is called acceleration. In the first case, time interval 0 seconds to nearly 10 seconds, body speeded up. And the acceleration is not a constant, variable acceleration, but still speed increased. Later on, velocity became constant, acceleration becomes 0. After that, velocity decreases at constant rate, then called retardation, constant retardation. So, non-uniform acceleration, zero acceleration, negative acceleration, like this. This type of graphs are to be interpreted clearly, then we will be easily scoring. Now, this solved example is also important. You go through solved example for finding average velocity between 2 second and 4 second for such an equation. X is equal to a plus bt square. That is position. Taking the first derivative, you got velocity. That is 2bt. Then t equal to 0, velocity is 0. T equal to 4 second, velocity you can find out 2 into b into 4. B is given 2.5. Like that, we can find out average velocity. You can find out instantaneous velocity at any time interval. Okay. Uniform motion, not that for uniform motion, velocity is same as average velocity at all instants. Uniform velocity means velocity, average velocity is a constant. You can see this graph is also important. Acceleration time graph. From acceleration time graph, area under acceleration time graph, you can find change in velocity. Area, here positive area, 0 seconds to 10 seconds, area is positive. So change in velocity positive. Initial acceleration 0. Acceleration at 10 seconds is 4.8 meter per second square. Then change in velocity becomes negative for 18 to 20 seconds. Change in velocity becomes 0, 10 to 18. 10 to 18 acceleration is 0. So change in velocity is 0. Body moves with constant velocity from 10 to 18 seconds because acceleration is 0. 0 to 10 second acceleration going on increasing. You measure the area under the graph, then you will get change in velocity. What is the area under the upper part of the graph? Upper part area, half into base into altitude. Lower part area, length into breadth. What is the length? 2. What is the breadth? Breadth is this height. It's approximately up to 12. 12. So that is 24 with minus sign because that is the negative area. Here it is 48 by 2, 24 plus 24. So what is the total change in velocity? Plus 24 minus 24, that becomes 0. Change in velocity becomes 0 in this case. Initially and finally, but during the course of the journey, velocity is there. It's not 0, but change in velocity initially and finally becomes 0. So these type of questions are very Important. Also, this graph, you can go through this graph. Position time graph for body is moving with positive acceleration, negative acceleration, zero acceleration. First case, it's a curve showing the variation like this: acceleration positive, acceleration negative. Here acceleration zero because velocity is a constant. Here this graph also, velocity time graph is a straight line, but initial velocity is not zero. Slope is a constant, so acceleration constant. Here initial velocity is positive, but slope is constant, but slope is negative, so it is negative acceleration. Okay, speeding down, speed decreases, retards, body retards. This one, slope is positive, so body accelerates. Here, slope is negative, positive, slope is positive, right? Here slope is positive, velocity time graph, slope is positive. Here slope negative, so slope positive, slope negative, slope negative, slope negative. So here slope positive means acceleration positive, acceleration negative, acceleration negative, acceleration negative. From that negative acceleration, it tells that the direction of acceleration is vertically downward. That's all. That's the meaning. So what's the physical situation that we have to see? In D, option C, D, we see that D. Motion of an object with negative acceleration that changes direction at time t1 between 0 and t1. It moves in positive x direction, and between t1 and t2 moves in opposite direction. 0 to t1 positive direction, t1 to t2 negative direction. So direction changes at t1. Okay. It may be a body projected vertically upward with speed v0. Then speed goes on decreasing. Speed becomes 0 at t1. So t1 should be the time to reach the top. And t2 is the instant of time when it reaches ground back. And that speed is minus v. It is not v0. That may be due to friction. Speed may have decreased. So time of ascent is not equal to time of descent. Time of descent is to be greater than time of ascent, but here it is graphically is given less. Okay, anyway, it's not a situation what we discuss here. We can compare in some of the situations. Option number B, C, motion in positive direction with negative acceleration. Velocity is in a positive direction but negative acceleration. First one, motion is positive direction with positive acceleration. C, motion in negative direction with negative acceleration. So velocity is negative here throughout. Here velocity first positive then negative. So change of direction is involved in the third, fourth case only. Like that questions may be asked. Okay, so this one is also important. Like that, few more graphs. Velocity time graph is a straight line with constant velocity. So uniform velocity. Area under velocity time graph gives displacement. Here, area under velocity time graph, total area of the trapezium will give you displacement. Area under velocity time graph gives displacement. So graphs are much more important in this chapter. So kinematic equations for constant acceleration, it is written. This formula is very important. For finding average velocity, we get V initial plus V final by 2. That is only for constant acceleration. That is to be noted. Kinematic equations I will write down in the next page, and we will solve few of the exercises, including motion under gravity. See, let me interpret these graphs, few more graphs. Here this graph may be representing a body moving with constant acceleration 9.8 meter per second square. This is exactly given minus 9.8, so it may be a freely falling body. Acceleration is constant and is minus 9.8 because it is direction convention we followed is downward direction negative, vertical direction downward negative. So here minus 9.8 means acceleration is negative. Here one more graph. Velocity time graph is a constant slope, having a constant slope, negative slope, minus 9.8, it may be minus 9.8. While finding out the slope, half into, slope dy by dt. What is that? Minus 50 divided by 5, minus 10, very close to minus 9, but it's a typical graph. So minus 9.8. So body falling freely, its velocity time graph is this. Body falling freely, its acceleration time graph is this. So acceleration time graph of a freely falling body is this one. Velocity time graph of a freely falling body is this one, second one, and position time graph of a freely falling body, that's a parabola. So note it, position time graph of freely falling body, parabola. Velocity time graph freely falling body, straight line. Acceleration time graph of a body, straight line parallel to time axis. See, all we have plotted in third quadrant, that is to be noted. Okay, now let me conclude all these things here. Kinematic equations. The first kinematic equation, V is equal to V0 plus AT. Okay, we can apply this one in many of the situations. For example, a car is moving in a straight line. A car is moving in a straight line. A car is moving in a straight line at t equal to 0. Initial velocity is v0 and is retarding. So in between at some instant of time t equal to t, its velocity is towards right, but its acceleration is towards left. If velocity and acceleration are in opposite directions, the body is speeding down, speed decreases, retards. Okay, velocity is to give positive sign, acceleration is to give negative sign. Okay, here it becomes velocity 0, final velocity becomes 0. Final velocity becomes 0 at this instant of time. Let that time t is equal to t0. Then what is the stopping time? We can use v is equal to final velocity 0 equal to u, initial velocity v0, that is positive, plus a is minus a into t is t0 is the time interval. Then we write v0 equal to at0 and t0 equal to v0 by a, or a equal to v0 divided by t0. This is the way by which we find the solution to a problem in kinematics. Care should be taken while assigning signs. Okay, what is the distance from here to here? There we use other kinematic equation. Which one is that? Let us choose the same situation to understand, make you understand the formula. S is equal to, or x minus x0 is equal to v0 t plus half a t square. X minus x0 is called displacement or sometimes called s. v0 t plus half is t square. Okay, here we apply this. S is the stopping distance after which it gets stopped. S is equal to v0 into t plus half into a is minus a t0 square. v0 t0 plus half minus a t0 square. We can use this formula for finding the stopping distance. One more equation, kinematic equation is there. That is v square minus v0 square is equal to 2as, where s is x minus x0. That equation, if we use 0 minus v0 square is equal to 2 into minus a into plus s. S is positive because it is measured to the right. That is, s is equal to v0 square divided by 2a. Also you can write V0 square divided by 2 into A is V0 by T. Substitute from here. V0 by T. One V0 gets cancelled. So you get S as V0T divided by 2. Another formula for stopping distance. Lots of questions are asked in examinations based on this concept. So this page is very important. For example, an aircraft takeoffs. During taking off, it needs some minimum length of runway required. So what should be the minimum length of runway required if the takeoff speed is V0? If the takeoff speed is V, something like that, then we can use the length of the minimum length of the runway as V0 square by 2A. If V0 is the takeoff speed, A is the acceleration. So you can use this same equation for finding the accelerating distance. Okay, where A is the maximum acceleration of that airplane. V0 is the takeoff speed. S is the minimum length required for the runway. A is the maximum acceleration. Okay, also that may be based on this laws of motion and all. Maximum frictional acceleration is mu g. So V0 square by 2 A is substituted as mu into g, where mu is the static coefficient of friction. G acceleration due to gravity. All that may be asked. Stopping distance problem can be based on this equation also. What is the time interval after which it gains a speed is V0? Over what length? Length is equal to V0 T by 2. A person picks up a speed 6 meters per second from rest in 3 seconds. Then what is the minimum length of the track required for an athlete? That may be asked. Then S is equal to V0 T by 2. Stopping distances, stopping time, accelerating distance, accelerating time, stopping time, all this may be solved by using these two sets of equations. One is V square by 2A, V0 square by 2A, other is V0 T by 2. Okay, or V0 T0 by 2, whatever you can substitute. V0 T0 by 2. T0 I used stopping time, where T0 is the stopping time. Stopping distance, very important, stopping distance. Most of the papers we used to see this one, stopping distance. Let us write down the equation alone. S is equal to V0 square divided by 2A, or S is equal to V0 T by 2. Then if you have V0 T graph, V0 T graph, how to find out stopping distance from V0 T graph? If V0 is a variable, T is also variable. In such situations, V0 and T, if variables, we can make half into V0 into T as the stopping distance. S is equal to V0 square divided by 2A. So S proportional to V0 square. That's very important question. If V0 doubled, speed doubled, stopping distance become 4 times. If speed halved, stopping distance become 1/4. If speed tripled, stopping distance become 3 square, 9 times. Speed 1/3, stopping distance become 1 by 3 square, that is 1 by 9. Speed quadrupled, stopping distance become 16 times. Speed 1/4, stopping distance becomes 116. Now percentage type problems. Speed increased by 10%. If speed increased by 10% plus 10, then stopping distance increased by plus 21. This type of questions are also asked. You can quickly come to this answer. V0 square, 10 becomes 21. How? See, 10 into 2, 20, plus 10 by 10 square, that is 20 plus 1, 21. Suppose speed delta V0 by V0 decreases by 10%. Then stopping distance also decreases by what percentage? By 19%. How? You just make use of a minus sign here. So it may become plus 21 or minus 19. Okay, these type of questions are very popular from most of the chapters. Wherever you have power of one variable is 1, power of the dependent variable is 2, and is a quadratic following a parabolic graph between them. S B0 graph is a parabola symmetric about S axis. S the power of S is 1. The quantity has whose power is 1, that should be parabola symmetric about that axis. So if speed increases by 10%, stopping distance increases by 21%. Speed decreases by 10%, stopping distance decreases by 19%. Repeating for one more. If speed increases by 20%, speed increases by 20%, stopping distance increases by 20 into 2 plus 20 by 10 square, that is 44%. Like that, if speed increases by 25%, 25 into 2 plus 25 by 10 square, that implies 50 plus 6.225, that is 56.25. Even be easy to handle with fractions by using this shortcut. If subtraction, when subtracted, plus or minus, when plus or minus, when this is plus or this is minus. Okay, then this one will be plus 44. This one you plus or minus. Okay, you understood. I hope that you understood. So stopping distance speed relationship, many competitive examinations we used to see. Okay, now motion under gravity. We are going to practice one-dimensional motion, kinematic equations, all that we have written. Body starting from rest. Galilean law of odd numbers. Galilean law of odd numbers. Okay. Galileo found that a body starting from rest, the total time interval after which it falls on to ground is equally divided into whatever time intervals. Time intervals may be bigger or smaller. You divide the total time of pre-fall into equal time intervals. Then the distance traveled by it in the successive time intervals, equal successive time intervals starting from rest, follow the ratio 1:3:5:7:9. That is called Galilean odd number ratio. Based on that, many observations and most of the problems based on this motion under gravity can be solved so quickly by using this Galilean observations. Okay, for example, last year also mains a question was asked based on water falling from a tap, water tap. Okay, say there are 3 drops in air. While we are watching and taking a photograph, you take a screenshot of this video. In that screenshot you saw 3 water drops in air. One here and one here. The first drop reaches ground, just about to reach ground. Third drop just about to leave the tap. Middle drop. Second drop is in air. You have the screenshot, you take the screenshot. Then, if this height is given as 5 meters, what is the distance between first drop and second drop? What's the distance between second drop and third drop? You can easily solve if more number of drops are also there. As per Galilean law, this time interval is delta t equal to 1 second. You divide the total time into equal intervals. This time interval also delta t equal to 1 second. The total time divided equally. Okay. Then this distance will be, if this distance is 1 meter, this should be 3 meter, that is Galileo saying. So, if this distance is x, that's what is this distance? That should be 3x. So, x plus 3x is equal to 5 meter. That is 4x equal to 5 meter. That is x is equal to 5 by 4 meter. that is 1.25 meter. So this distance is 1.25 meter. Then this distance will be 3 times 3.75 meter, so and so. Okay, then this is the distance traveled in first 1 second. First 1 second. First 1 second. This is the second 1 second. This is the third 1 second. And this is the fourth 1 second. So what is the distance traveled in second 1 second? 3.75. What is the distance traveled in first 1 second? 1.25. Okay. What is the difference between these two? 3.75 minus 1.25. 0, 5, 2, 2.5. Then take half of that. You get 1.25. That will be the distance traveled in first 1 second. So whatever quantities you are given with, like this ratios, first 1 second distance, second 1 second, third 1 second, fourth 1 second, fifth 1 seconds, you may have been given with the seventh 1 second and eighth 1 second distances. You take the difference between the two neighboring distances. Take the difference between any of the two neighboring distances. Take exactly half of that, you will get the distance traveled in first 1 second. That is Galileo's first observation. And that is called Galilean law of odd numbers. Okay, based on this one, the last year mains question was this. Okay, this can be extended to 5 or 7 or whatever number of droplets. Any freely falling bodies, you can apply this. Okay, this can be again similar type of questions are also asked. If h is the height of a tower, a stone is dropped from rest, u is equal to 0. U is the initial speed, or v0 is 0. When it reaches here, it travels some distance in the last 1 second. In the last 1 second, it travels a distance of, say, 3h by 4 meter. 3h by 4. 75%. That means 75% of its entire height is covered in the last 1 second. Then what is the time it has fallen down? What's the height of the building? You can make use of these Galilean observations to answer it quickly. In such a case, you just take the square root of the denominator. But the problem should be exactly identical, right? Take the square root of the denominator. That will be the time to reach down. Suppose it begins at t equal to 0, stopwatch just started. When it reaches here, t is equal to, take the square root of 4, 2 seconds. So what's the time to fall down? 2 seconds. One more method. You just add 1 to the numerator coefficient, 3. 3 plus 1 is equal to 4. You take half that. 4 by 2 equal to 2. So 2 seconds is the time for free fall. If time for free fall is 2 seconds, height h is equal to ut plus half at square, but u0 half at square, g nearly 10. 10 by 2, 5. Shortcut, 5t square. 5 into t2, 2 square. 5 into 4, then 20 meter. So height of the tower is 20 meter. Next possibility. Suppose in last 1 second it covers a distance. Let me show in another color, don't confuse. Okay, that may be 5 divided by. Next one, you see. So any one of these only will be asked. That's interesting. Before previous question papers, only that. Okay, this need not be a perfect square. Need not be, but still we can find out. Okay, anyway, that's square root of the denominator would lead to the time of flight. Time for free fall. Then 5 times, exactly 5. If g is equal to 10. Don't forget. 5 times square of flight time will be the height of the tower. If it is 5h divided by 16, 5h by 16. You just add 5 plus 1. 6. No. Square root of 16. 4. Like that you followed here. 5 plus 1. 6. 6. Then it should not be 6, right? 3. 5. It should be 9, right? It should be 9. Next one. Made a mistake. Okay, now it's correct. 9. What is the square root of 9? 3. So what is the time for fold? 3 seconds. So 5 plus 1, 6. 6 by 2, 3. Right. 5 by 9h. Next possibility. So what is the height? 5 into 9, 45. Next possibility. Next one is 7h by 16. 7h by 16. 7 plus 1, 8. 8 by 2, 4. Root 16, 4. In whatever way you can try it. Okay. So this is another one. It's a very popular question. Every year, mains paper, we used to see this question. Distance traveled by a stone falling from rust from the top of a building covers a distance of 75% is in the last 1 second of its entire falling journey. Then what is the height of the tower? That's fixed. That has a fixed answer because of this constancy of acceleration due to gravity. Okay. Similarly, if you have the total distance h, last year 2022 mains also this similar questions was asked. Total height is h. You divide total height into equal compartments like this. And this one is h by 4, this one is h by 4, this one is h by 4, h by 4, h by 4. Into 5 parts, equal parts I divided. The time interval for this is 1 second. Then time interval for this is how much? Root 2 minus root 1 seconds. Time interval for this one is root 3 minus root 2 seconds. Time interval for this one is root 4 minus root 3. And for this one is root 5 minus root 4. So root 2, 1. If it is 1 second, this is root 2 minus root 1, root 3 minus root 2, root 4 minus root 3, root 5 minus root 4, so and so you can continue. Provided this height should be divided equally. That is also Galilean addition. And both for downward as well as upward journey it is true. Okay, 2022 paper, a tough question was there, but which could be simply answered by using these arguments. So motion under gravity, Galilean observations important here. Galilean observations can not only be applied to motion under gravity, it can be also applied to any kinematic one-dimensional motions with constant acceleration, provided it should start from rest or end up with rest. Okay, time intervals should be same or distance intervals should be same, whatever what we have discussed as it is. Okay, let us now complete the rest of the part of the chapter. A few more exercises. Time for free fall. Time for free fall. A body starting from rest, falling from rest, what time it reaches ground? If height is h, time for free fall is equal to square root of 2h by g. What velocity it touches ground? Velocity equal to root 2gh. This one is also important. Time for free fall root of 2h by g. If h is equal to 9.8 meter, time for free fall is root of 2 into 9.8 divided by 9.8, that is equal to 1.414 seconds. What is the velocity? V equal to root of 2 into 9.8 into 9.8, that is 9.8 root 2 meter per second. Like this, velocity after some time. What is the velocity? What is the acceleration? Acceleration is a constant. After some time, velocity becomes equal to acceleration. What is that time? 2022 mains question. Falling down. When it reaches here, velocity is equal to acceleration is given. Acceleration is acceleration due to gravity. Starting from rest, also at t equal to 0. Let the time here in reaching is t0. So use the kinematic equation. u plus at, but u is 0 here, a is g, so gt 0 equal to g, so t0 equal to 1. After 1 second, velocity becomes equal to acceleration. After traveling what distance it happens so? Then you use velocity becomes acceleration due to gravity after traveling what distance? Then you use v is equal to root of 2gh if h is the distance traveled within that time interval. That is equal to g. Velocity formula v equal to g is to be substituted, but v the other formula root 2gh. That is 2gh is equal to g square. G get cancelled on squaring. Root removed. Then 1g cancels. H is equal to g by 2, that is 5 meter. If g is taken as 10 meter per second square. Then after traveling 5 meter distance, velocity becomes equal to acceleration. After traveling 1 second time, velocity becomes equal to acceleration. These type of questions are very important. Okay, for kinematics, motion under gravity. It can be also applied to straight line, not only for gravitational field. Okay, anyway, sign conventions are very important, students. When you deal with sign conventions, when a car is moving to the rightward direction, car is moving to the rightward direction, like this. Velocity is given positive. If its acceleration is also towards right, that is also positive, then speed increases. So angle between velocity and acceleration is angle between velocity and acceleration, angle theta equal to 0. But if theta equal to 180, speed decreases. So in one dimensional motion, the angle between velocity and acceleration, there can be only two possible values. Can you guess what are those values? Either 0 or 180. 0 if speed is increasing, 180 if speed is decreasing. Okay, in one dimensional motion, there are only two possibilities of angles between speed, velocity and acceleration. 0 or 180. 0 means speed increasing, 180 means speed decreasing. When a car is stopping, its velocity and acceleration are in opposite directions. So this type of theory, that basic ideas learned in theory are not to be forgotten, revise as many number of times. Okay, motion under gravity is very important. The chapter, these concepts are asked for most of the competitive examinations. Then relative velocity, based on questions, relative velocity. Relative velocity in one dimension. Velocity of a car A with respect to B is equal to velocity of A minus velocity of B. This is only in one dimension. Two cars A and B are moving in positive direction of x-axis with different velocities. A person in car A watches a person in car B, or person in car A watches the car B. What is the velocity of the car B as seen by the car A? Velocity of the person, velocity of the car B as seen by the person in the car A is VBA. Velocity of B with respect to A, that is equal to VB minus VA, and also VAB equal to minus of VBA. Okay, as it is kinematics in straight line, you need not put vector sign. For guiding into the direction convention, we use only plus or minus signs by Cartesian convention. So VAB equal to minus VBA. Okay. This we have to use proper conventions, sign conventions. We solve a problem which is here in NCERT. It's a solved exercise and very important one. Okay, let me cut that one and take into the other page. See this one. This question will let us go through. Two parallel rail tracks run north-south. Train A moves north with speed 54. Two parallel tracks. These are the two parallel tracks. Two parallel tracks. And each of those parallel tracks trains are running. like this. Train A and train B. North, south. Let us choose for simplicity north as this one, south here. Train A moves northward. Train A moves northward with velocity of A. Train B moves southward. Velocity of B is southward. And this A54 convert into meter per second. How to convert? Kilometer per hour into meter per second. Multiply by, tell me, 5 by 18. 5 by 18. So that should be 15 meter per second. 15 meter per second. Northward direction you choose plus sign. Then southward direction you choose minus sign. 90 into 5 by 18. It should be 25. So minus 25 meter per second. 90 into 5 by 18. 25 should be minus 25. Now, what's the velocity of B with respect to A? Start. Question number 1. Velocity of B with respect to A equal to VB minus VA. What is VB? VB is already minus 25. Minus. Don't forget to put the minus in between. VA. VA is plus 50. Plus 50. That is equal to minus minus 25 minus 15, that implies minus 40 meter per second. Question number B. Velocity of ground with respect to B. Velocity of ground with respect to B equal to velocity of ground minus velocity of B. Velocity of ground is at rest minus velocity of B minus 25. That is equal to plus 25 meter per second. Next one and the last one. The thing is that there is a monkey running on the roof of train A. There is a monkey running on the roof of train A against its motion. That means the monkey is running against southward, speed 18 with respect to A, as observed by a man standing on the ground. So what is the velocity of the monkey? We have to find velocity of monkey running on the roof of the train A against its motion with a velocity 18 with respect to A, as observed by man standing on the ground. We have to find out the velocity of the monkey with respect to ground. So velocity of the monkey with respect to train A is equal to velocity of monkey minus velocity of A. What do you mean that? Velocity of monkey means velocity of the monkey with respect to ground. Velocity of A means velocity of train A with respect to ground. Here we need velocity of monkey with respect to ground. So Vm is equal to Vma plus Va. That implies, what is velocity of monkey with respect to A? That is given 18. 18 is into 5 by 18 becomes 5. So 5 plus or minus. That's very important. Velocity of monkey running on roof of train A against its motion. So A is moving due north. North is positive, but against means south, that is negative. So minus 5 plus velocity of A with respect to ground. Velocity of A with respect to ground is plus 15. Plus 15, so it should be plus 10 meter per second. Plus 10 meter per second is the answer. Like this, these problems can be solved. Relative velocity based questions involve graphs also. That graphs I will explain by using these graphs given in textbook. Here, first graph. This graph tells you what? Position time graph, first body. Position time graph, first graph, you see the first graph. It's a straight line. Position time graph, straight line, inclined to time axis means the body moves with constant velocity. Slope is positive, so velocity is positive. Slope of A is also positive, and these two graphs are parallel to one another means they are having same slope. Parallel means slope same. Slope same means velocity same. So both the bodies have got same velocities. As the bodies A and B have got same velocity, the relative velocity becomes 0. So VA equals VB. So velocity of A equal to velocity of B. So relative velocity becomes 0. Then the next one. See the next one, position time graph. Slopes are different. Not. Slopes are different for different velocities. Slopes are but their own slopes are constants. So relative velocity is constant. Then slope of A is greater than that of B, right? A is more steeper. So slope of A is greater, so velocity of A is greater. So what is the intersecting point meaning? At that time, 3 seconds, velocity of A and velocity of B, you see, they are meeting at say, velocity of A is greater at 3 seconds, velocity of A is not equal to velocity of B. At every instant of time, A is faster than B because slope of A is greater. So at that time, 3 seconds, they are at same position. What is that position? We can find out that position by extrapolating here, close to 70 meter. That means at 70 meter distance from origin, 70 meter distance from origin, A overtakes B. These type of questions may be asked. Statements may have been coming based on these graphs. Okay, so interpretation of graphs and tables very important. So at 3 seconds, A overtakes B. At every instance of motion, A is faster than B. At no instant, B is faster than A. But at t equal to 0, A was at 10 meter. At t equal to 0, B was at 40 meter. So B was ahead of A. By what distance? 30 meter. B was ahead of A by a distance of 30 meter. Okay. Both were starting together, but B was ahead. That's why it took 3 seconds for A to overtake B. A took 3 seconds to overtake B, and overtaking occurred at a distance of 70 meter from the origin. That type of questions may be asked. Okay, right? Next one more graph. The next graph you can see. The next graph. Let me see that graph. Okay. And that graph is a straight line. A has a straight line but positive slope. B has a straight line constant but negative slope. What do you mean by that? Their velocities are in opposite direction. A has a positive velocity, slope is positive. B has a negative velocity, slope is negative. So A and B, they are moving in a straight line in opposite directions. So how to find out their relative velocity? VA is positive, VB is negative, so VA minus VB automatically becomes VA plus VB. So that 1 second has what significance? At 1 second they are crossing. What is a crossing? At the instant 1 second they starting from the 0 beginning, they started to cross at 1 second. They crossed at 1 second. What is a crossing position? 30 meter from equilibrium, 30 meter from origin. Okay, what is the relative velocity? Relative velocity is positive. So relative velocity questions may be based on this type of graphs. Very important. Okay. As it is a revision program, we are little fast, but don't worry. You just go through this textbook, and if there is any doubt, you can clarify it. Okay. Here reaction time something is written. Reaction time, one can find out the reaction time by using an exercise. If you find your reaction time, you hold a scale in your hand and ask your friend to hold the scale and leave it at t equal to 0, and you do not allow the scale to fall down. So you, as soon as it is left by your friend, you just try to catch it. Find out that time at which you catch it. You cannot easily find out the time interval by using a stopwatch. So you measure the distance moved by the scale within which you hold it. That may be very few, maybe 1 millimeter or fractional millimeter, whatever. Okay, you can find out the time by using time for free fall, root 2h by g. H is that distance, maybe 1 millimeter. G 9.8. then you can calculate an approximate value of your reaction time. That reaction time is a good one in engineering while finding out the response time of a driver of a vehicle. Reaction time of driver of vehicle should be as small as possible. He should quickly decide whether to apply brake or not to apply brake before a collision occurs. Sometimes he may have to change the direction to avoid collision. Sometimes he may have to apply sudden brakes. The choice is the driver's. At that moment, he cannot consult his friend or consult any experts to decide whether apply brake suddenly or not. So that sudden decision makes a driver perfect, for which reaction time of that driver should be as small as possible. Okay, that can be found asked frequently in this stopping distance type questions, right? That's relative velocity. So let us have a quick revision once again. We have to start from path length. Path length. Path length is the actual distance traveled. Path length is the actual distance traveled by the moving body. Displacement is the change of position. Position, path length, displacement. Displacement, velocity are vectors, but path length, distance, all are scalars. What do you mean by a frame of reference? Frame of reference is any object with respect to which other bodies rest or motion is specified. മറ്റു വസ്തുക്കളുടെ ചലനാവസ്ഥയോ നിശ്ചലാവസ്ഥയോ കുറിച്ച് പഠിക്കുന്നതിന് വേണ്ടി ഏതൊരു വസ്തുവിനെയാണോ നമ്മൾ അവലംബകമായിട്ട് എടുക്കുന്നത്, ആ അവലംബകത്തെ വിളിക്കുന്ന പേരാണ്, അതിന്റെ മലയാളം അവലംബകം എന്നാണ്. ഫ്രെയിം ഓഫ് റെഫറൻസ്. A coordinate system, maybe a Cartesian coordinate system attached with a clock can be an example of a frame of reference. Okay, frame of reference. Everything in the universe are relative. Everything, nothing is absolute. എല്ലാം മറ്റൊന്നുമായി ബന്ധപ്പെടുത്തിയിട്ടാണ്. എല്ലാം നമ്മുടെ ഡെയിലി ലൈഫിലെല്ലാം നമുക്കതറിയാം. മറ്റുള്ള കുട്ടികളുടെ മാർക്ക് കണ്ടില്ലേ, കുറവാണല്ലോ നിങ്ങൾക്ക്, അല്ലെങ്കിൽ അവളേക്കാൾ നിങ്ങൾക്ക് കൂടുതലാണ്, നിങ്ങൾക്ക് കുറവാണ്, എന്ത് കണ്ടാലും കമ്പയർ ചെയ്യുന്ന ഒരു സ്വഭാവം മനുഷ്യനുണ്ട്. അതെല്ലാം റിലേറ്റിവിറ്റിയാണ്. എവറിത്തിങ് ഈസ് റിലേറ്റീവ്. ഇന്നലത്തേതിനേക്കാൾ ഇന്നത്തെ ഫുഡിന് ടേസ്റ്റ് കൂടുതലാണ്, ഇന്നത്തേക്കാൾ ഇന്ന് ചൂട് അല്പം കുറഞ്ഞു, കാലത്തേക്കാൾ ഉച്ചയ്ക്ക് ചൂട് കൂടി കുറഞ്ഞു, ഇതൊക്കെ ഇന്നലത്തേക്കാൾ മഴ ഇന്ന് കുറച്ചാണ് പെയ്തത്, ഇതെല്ലാം റിലേറ്റിവിറ്റിയാണ്. ഓക്കെ, അപ്പോൾ എവറിത്തിങ് ഇൻ ദ യൂണിവേഴ്സ് ആർ റിലേറ്റീവ്. അബ്സല്യൂട്ട് റെസ്റ്റ്, അബ്സല്യൂട്ട് മോഷൻ ഈസ് മീനിങ്ലെസ്. Distance, displacement, instantaneous velocity, instantaneous speed, average velocity, average speed. How to find average speed? Total distance by total time. Average speed we can find by using this formula, total distance by total time. But there is some shortcuts. If the total distance is equally divided into two equal distances, ആദ്യത്തെ ഈക്വൽ ഡിസ്റ്റൻസിൽ സഞ്ചരിച്ച സ്പീഡ് v1 ആണെങ്കിൽ രണ്ടാമത്തെ ഈക്വൽ ഡിസ്റ്റൻസിൽ സഞ്ചരിച്ച ആവറേജ് സ്പീഡ് v2 ആണെങ്കിൽ ടോട്ടൽ സഞ്ചരിക്കുന്ന ദൂരത്തെ രണ്ട് ഈക്വൽ ഭാഗങ്ങളായി ഡിവൈഡ് ചെയ്യുകയും അതിൽ ആദ്യ പകുതിയിൽ സഞ്ചരിച്ച ആവറേജ് സ്പീഡ് v1 ഉം രണ്ടാമത്തെ ഈക്വൽ പകുതിയിൽ v2 ആണെങ്കിൽ ഏത് ഫോർമുലയാണ് ഉപയോഗിക്കുക? ഓർമ്മയുണ്ട്? ഹാർമോണിക് മീൻ എന്നാണ് അതിന് പറയാ, അല്ലെ? 2v1 v2 by v1 plus v2. മൂന്നെണ്ണെങ്കിലോ ടോട്ടൽ ഡിസ്റ്റൻസ് 3h ആണ്. അതിനെ h ആയി കമ്പാർട്ട്മെന്റുകളായി ഡിവൈഡ് ചെയ്തു. ആദ്യത്തെ hൽ v1, സെക്കൻഡ് h v2, തേർഡ് h v3, then 3v1 v2 v3 by v1 v2 plus v2 v3 plus v1 v3, v1 v2 v2 v3 v1 v3. ഇതുപോലെയാണ്. അതിനൊരു ഷോർട്ട് കട്ട് വീണ്ടും ഉണ്ട്. n is the number of divisions. n by v average. n by v average equal to 1 by v1 plus 1 by v2 plus etc plus 1 by vn. എത്ര എണ്ണം ഉണ്ടോ അത്? അവിടെ ഹാർമോണിക് മീൻ ആണ് ഉപയോഗിക്കുക. But if the total time of journey is equally divided into two equal halves, total ടൈമിനെയാണ് ഈക്വൽ ആയി ഡിവൈഡ് ചെയ്യുന്നതെങ്കിലോ there we have to use v1 plus V2 by 2, that is arithmetic mean. Total time ആണ് divide ചെയ്യുന്നതെങ്കിൽ V1 plus V2 by 2. അത് മൂന്നെണ്ണം ഉണ്ടെങ്കിലോ V1 plus V2 plus V3 by 3. Any number you can practice it. Okay. Then we have discussed the graphs and all important kinematic equations. Okay, don't forget to go through this chapter, read this chapter once again. Here tables are not so relevant, but graphs are relevant. But in previous chapter, tables also were relevant. Here this type of graphs are very important. Freely falling is a very important exercise that we have to do number of times. Go through the textbook. Based on this textbook only questions will be asked. Okay, read it thoroughly, repeatedly, and try to answer numericals, try to answer statements, try to answer matching, paragraph, passage type, all the type of integer, everything depending upon, based on your examinations. Whatever examination you are going to write. Stopping distance you don't forget. Okay, stopping distance equations very important. One more formula I will tell you for stopping distance. Not it. Initial kinetic energy divided by retarding force. Let me write it on the board. Stopping distance is equal to initial kinetic energy divided by retarding force. Stopping distance is equal to initial kinetic energy divided by retarding force, where ma is the retarding force, a is the retardation, v0 initial speed, ei initial kinetic energy. So initial kinetic energy equal to retarding force into stopping distance. Initial kinetic energy is equal to the rate of change of momentum times displacement. Like this, these questions all have a very good past, asking all this. So previous papers do many things. Previous papers, at least you do 3-year previous papers after going through this chapter NCERT text thoroughly. Okay, so we have completed that second chapter and NCERT chapter 3 kinematics. We'll be soon meeting with the next chapter. Thank you.